Hello, I'm Eric Snodgrass, and thank you for watching this Ag Forecast brought to you by Nutrien Ag Solutions. Today's analysis is going to be a bit longer than normal because we have some brand new long-range weather updates to get talking about from the European model. So let's start discussing what went into these long-range updates by first looking here at the last 6 months of precipitation. So the map, again, I like to show these from Iowa State here. Look at the precipitation rank over the last 129 years. So this goes from November the 6th through May the 6th. And what you've got here is a kind of a story of the western United States going over very dry. We know how dry California has been as of late, having one of its driest Aprils on record. But then the whole 6-month time period received about 50% of normal precipitation. That's critical for the upcoming forecast. It has been very dry lately in the Pacific Northwest, and we've continued the drought pressure here in the northern plains as well. Much of what you see that's in this area came through in March with some of those big storm systems in March. And although it looks wet over here in parts of the mid-Atlantic and along into the Carolinas, as of late we've had some drier weather in pockets in this area. Another area to be watching out for is this section of the Great Lakes Basin getting into the eastern Corn Belt. And then we're going to talk in a few moments about what's been going on as of late in the state of Iowa. Okay, so this is the backdrop. The model was initialized knowing that this is what the precipitation patterns have been over the last 6 months. So from there, we look at the drought monitor that was released last week. Now, in about 5 hours from when I'm recording this, we're going to get a brand new one of these. But this is just showing us where the extent of the drought currently is across the United States. And we can see that it matches quite well with the previous figure that we're going to talk about. Now, in a few moments, I really want to hone in and have a discussion about what this could possibly mean for later on in the season. That might be the most significant piece to the puzzle when it comes to possibly overturning or upsetting what the longer range models are going to look at. So we're going to come back to that in a few moments. But let's go straight to our soil moisture map. This is the top 100 centimeters. So we're looking at basically the top 3 feet of soil in terms of moisture and percentile. And you do see, when we kind of see these numbers down here, it is that pocket in the eastern Corn Belt. We do have the dryness that's here in Iowa, southern Minnesota, parts of Wisconsin, and a large area here that has been exceptionally dry as well. Where most of our heavy precipitation and the severe weather has been in the lower Mississippi River Valley, coming out of the Red River Valley and then moving on off to the east. So again, we can just kind of get a good look here at, through the depth of the profile, based off of some of the measurements by NASA, what we're looking at in terms of soil moisture. Okay. Bigger picture things we have been discussing have centered around ocean temperatures. And we remember from last time that very few variables serve as predictors that show statistical significance with long-range weather forecasting. And therefore, water temperatures and their differences from normal are one of those predictors. And so we've been looking at something called the PMM, or the Pacific Meridional Mode. Now, the data that you see here are showing us where it currently sits in the month of April. And it's almost 2 standard deviations below normal. And when we look at the values, they're right here. So it's that last dot right there, okay? So there's a bit of a bounce over where it was, in March, but we're currently sitting here. Now, the last time we saw values that were this low were really back here in 2012 and 2013. Now, just be careful. I know that using those years as an analog for the Pacific Meridional Mode might just start to get us thinking about what happened and what could happen. But the idea here is just to see where the index has been, because since then it made a large recovery. Now remember, when we're looking at this, it's all about ocean temperature patterns. And that negative PMM, look down here at the bottom, is characterized by the cooler water in this region with the warm tongue pushing into this area. This is also related to the PDO, or the Pacific Decadal Oscillation. But the idea here is that if we can use this as a proxy or an initial idea about what this upcoming summer might look like, we just have to go back and remember this. So let's blow this image up so it's a little bit clearer to see here. But we remember that when looking at the June to August correlation between precipitation patterns and the PMM, we know that the correlation is positive in a large area of the United States here. And what that means is if the PMM was positive, this would be wetter. I'll put kind of a W in it there. But the reality of it is the PMM is negative and currently negative, and therefore the risks would be for drier conditions here, and therefore our drought concerns moving forward would begin to increase. You do notice that along the west, we would see a negative correlation, meaning that a negative PMM could increase summer precipitation. And that's primarily driven by a monsoonal flow that comes out of the desert southwest, and the storms just kind of roll around that monsoonal flow. So this is one of many different background states. Now, I've looked at many others, including the changes in atmospheric momentum. Now, remember, those are generally subseasonal. The changes in atmospheric momentum are generally subseasonal. The MJO is a subseasonal weather parameter. And the QBO, the quasi-biennial oscillation. Sometimes I talk about it when it's very important. That's deep in the stratosphere over the equator. It right now is not constructively adding to this. So that's why I'm focusing here primarily on these ocean temperatures. Now, just as a reminder, what I did, and I know a lot of you are viewing my content from the primary corn and soybean belt. So I went back and reconstructed from 1948 to last year what the whole belt-wide precipitation pattern looks like. And so you've got this trend line saying, really over the last 70 plus years, we've increased by about an inch and a half overall in total precipitation. What I was interested in is these years where the precipitation values are extremely low. What had to happen to get them to come together to do that? So let's talk about that, because our ocean temperatures are part of that discussion. So this is the latest data on May the 4th, and a couple of very important notes I would like to make. We can see that as of late, we have started to push some of that warmer water, notice it here, closer and closer toward Washington State. And while we still maintain the cooler conditions in the Gulf of Alaska and the cool tongue of water that's coming off the Baja of California, and that's critical, plus the warmth in the North Atlantic, this overall discussion about the ocean temperature patterns increasing the risk of drought around the Mississippi watershed and in the western side of the Mississippi watershed, for example, those shifts of warmer conditions pushing farther toward Washington need to be taken note of. And the reason why is if we continue to erode the cooler water you see in this area with time, that will start to back off that risk. Now, since we're also looking at this figure, we need to have a discussion about what's going on with La Niña. We're going to primarily do this using ocean temperatures because the trade winds have slackened, and we're going to see what that means to what these ocean temperatures are going to do. And to do that, let's go look first of all at some correlation. Let's shrink that up so we can see it here. So I was very interested to know, when you look back at those really, really hot summers, June through August, for the primary corn and soybean belt, well, here are the years listed out in order, okay? We noticed that there was a large area of warm water here with cooler water along the coast and some warmth in the North Atlantic as well. But in this composite map, I've got some years like 1955, 66, 52, 70, 71. Some of these years are several decades ago when ocean temperature patterns were considerably different and cooler than now. So I'm going to remove them and replace them with some of the more recent drier years. And now we get a little bit better signal from this. You see, the El Niño-La Niña region tends to not be an important factor for summer. It tends to be where this warm tongue is here and how cool the water is off the coast and how warm the North Atlantic is, which we just discussed, all right? So keeping that in the back of our minds, let's just at least take a look at what's going on with our La Niña, which has faded. And this is the latest data we have. We've come out of last winter, fading those ocean temperatures in the Central Pacific. And their forecast, if you look at the ensemble mean, is to take them into neutral territory. That would be right here with an ocean temperature anomaly of about 0 in the middle Pacific. All right. But the spread is enormous. Some of the models are trying to bring this back into weak La Niña, and I'll be honest, there is some reason for that. And a few of the ensemble members are trying to actually take this into weak El Niño territory, which is up here. Now, with this kind of spread, this really has a major, this is a major indicator that some of the longer-term predictions for this upcoming summer, I don't have much confidence in them. And I really don't have any confidence in them predicting issues like regional drought, flash drought, or I really think they're not going to have an idea where the Bermuda high is going to be this year. I think that's going to be a thing they're going to really struggle with. So you notice if you go over here, this would be South America, okay? And this over here would be Australia. That line that connects the two right here across the top, that's the top of the ocean, right? And this is going down in depth. Now what you're watching here is going back through March and then into the month of April. This is kind of the warmer tongue of water that is now starting to surface right here where you saw those ocean temperatures moderating as of late. Now you start to look at this and you see this large plume of warmer water coming back. And again, these are ocean temperature anomalies. And you say, well, that looks to me like an El Nino is going to surface. But remember, in order for it to be an El Nino, you have to have a trade wind response as well. This is just the warmer water sloshing back after the stronger La Nina we've been experiencing. So I keep getting asked this question, and so I want to address it now. Let's come back to these ocean temperatures. The question's been about 2012. There's a lot of concern that the drought this year could be the worst that we've seen in a decade. And we know what our current drought situation looks like. So I would like to at least talk about the ocean temperatures from 2012. This is what they look like the day after Independence Day in the United States. Okay, so July the 5th. And a couple of things to note. We had already at that point started to see very warm water coming back into our El Nino, La Nina region right here off of South America. But the extent of the very cold water coming off the Baja, the extent of the cold water in the Gulf of Alaska, stretching all the way back over to Japan, was one of the major components that allowed the jet stream to kind of dip down a bit here in the North Pacific and then run much farther to the north. So in general, if we're going to see drought risk across, I'll be honest, anywhere in the United States, you push the jet stream north of its normal position, that's a major indicator. And these cold ocean temperatures help that along. If you then rob the momentum of the atmosphere, in other words, you push the jet stream north and slow it down, there's just nothing there to stir the atmosphere up to produce low pressure systems, and all you get are scattered storms. And they produce locally heavy rain, but you also get a large area of drought. Now, since we're talking about drought, I want to come back to the latest drought monitor. And because that question keeps coming up to me about the differences between now and 2012, well, this is the current drought monitor for 2021 as of April 27th, and this is 2012. Now, what I notice is the difference in the extent of the drought in the West and what was happening here over the Southeast in 2012. So again, this is 2012, this is 2021. And now that we've got this idea going, what I want to do is I want to show you the latest long-range forecast, okay? So let's stitch all this together and put it into these graphics. Now, what you're about to see, first of all, let's get this one more month out. There we go. This is the June, July, August forecast that I gave you a month ago using the April initialization. We talked about how through the plains, getting into the Pacific Northwest, that is where the European model and frankly, almost all the other weather forecast models that do seasonal forecasting had kept the greatest warmth. We have some new updates. Let's see what they look like. This is now June, July, August, but using the May initialization, which just happened yesterday. And what you note is that the greatest heat compared to normal still sits here into the Pacific Northwest. But you might be looking at this going, well, why did it back off in parts of Texas? I think a lot of that has to do with the initial conditions of the model. In other words, it was initialized cool because of the cooler weather that is coming through. I think that's a part of it. I think it's carrying that forward. You notice that in this forecast for June, July, August, that it is really minimizing the risk of extreme heat over the east. What I would make a case of is to say that the model doesn't quite yet have down whether or not the Bermuda High sits here over the North Atlantic or if it's going to move closer toward the U.S. coast. There are some indications that it could. But let's take a look from here. Let's go back another to the previous run. I'm going to switch you over toward the seasonal precipitation. So this would have been the June, July, August forecast from last month on precipitation. And we talked about the model was really aggressively going after the southwestern monsoon and a very active hurricane season, with the greatest extent of drought stretching through the plains west of the Mississippi toward the parts of the northern plains, Canadian prairie, and back here into the Pacific Northwest. Okay, latest run looks like this. We see the model backed off on what it was predicting for the southwestern monsoon. We see that it continues to keep this region wet along the coast, indicating possibly that the Bermuda High stays here, the flow comes around it like this, and probably an active hurricane season. It is also continuing to keep this region west of the Mississippi River dry and extending that through the Canadian Prairie. That's our latest update. Now from there, I would like to show you what the ocean temperatures are doing. So let's just step this out so we can get kind of a global view. And this is now the June, July, August ocean temperature pattern. We can see that the coolest anomalies in our El Niño La Niña region shift south and some warmer anomalies begin to emerge here. We still see the very large area of warm water extending closer and closer to the west coast. But there is this pocket of cooler water in through here, near average in the Gulf of Alaska. What might be missing is the cold tongue in this area, but warm in the North Atlantic, and that could be a major indicator on what we could see from this upcoming hurricane season. Now, when I look at all of this and start to put this all together, I'm going to just tell you one thing. These long-range seasonal weather forecast models exhibit very, very little skill. They cannot predict regional drought. They cannot predict flash drought. And what is going to be ultimately the most important factor, we'll come back to what I started with, drought. Now, to break the drought in the northern plains would require an entirely different flow pattern than one we have now. And to break the drought would be actually quite bad right now for them. And what I mean by that is it would produce so much flooding that we'd have a problem finishing putting this crop in. What would be ideal is if the pattern begins to shift later in the season. And I want to come back to what I first pointed out. What I cannot get over is how dry things are here in the Intermountain West and in the Great Basin. And why I'm concerned about that is our hottest and driest years east of the Rocky Mountains, but before you get over to the Appalachian Mountains, tend to produce a ridge, that sits somewhere here. Sometimes it's closer to like the 95th meridian, sometimes it's closer to the 100th, but it's somewhere in there, and the jet stream is very, very far to the north, flat, and doesn't have much momentum. Okay? Now, in the last few years, we have seen the ridge here, and the flow comes over the top of this ridge, and we end up getting storms later in the season that run in this direction across the midsection of the country, and then get over to the east. And the East Coast precipitation signal has largely been dominated by tropical cyclone activity. Now, if I could throw just a major caveat into the forecast from the European model, it would be the precipitation forecast for the plains all the way to the lower Mississippi, the whole of the Mississippi River Valley here, could be too dry if this area throughout the month of June gets very, very hot. Now, if it gets very, very hot, the likelihood of the ridge being here increases. And if it's here, the flow comes around that ridge and you end up getting northwest flow here. The problem is going to be in the Pacific Northwest. It's going to be in California because that pattern is not good for the West. It's a pattern that increases fire risk. It's a pattern that increases high evaporation rates, and it could put major stress on the crops in the West. But that's what we're currently looking at. Now from there, let's get into a near-term forecast, okay? This is what happened over the last couple of days. Back on May the 4th, if we get to the unfiltered reports here, 579 reports of severe weather, most of them coming from strong winds. And as I was looking at this was kind of incredible. Let me go show you some radar data here. I think the most impressive radar signals I saw back on the afternoon of May the 4th were right here just south of the Jackson, Mississippi radar. Do you see these there's actually 4 of them. Watch again, right there. 1, 2, 3, 4. 4 separate supercells that got just pulled into this large squall line that went racing through. And that squall line produced extremely heavy rainfall and very, very strong winds. We can see that if we go back here, all of the wind reports that came through Mississippi, Alabama, and then came up into parts of the mid-Atlantic. Now from there, I'd like to show you how much rainfall we did get over the last 7 days. And so you can see that a lot of those storms over the south, mid-south and over into the southeast were very, very strong. But there are also several holes in this, which we need to take note of as well. Lately, this is what's going on with our satellite imagery. So yesterday, Just going to watch this very quickly here. We did see some big storms kind of blow up right in through here. And there were some regions, pockets of brief but heavy rainfall that did come out right here in parts of Montana. But overall, this flow pattern, if I just kind of rock back and forth at the end of the day yesterday, tells me a lot about the way things are going to be shaping up here in the near term. And to get into that discussion, let's go straight to the jet stream level winds. All right, this is this morning. And as we play this forward, there we go, as we just kind of play this forward moving out here, I notice there's a rather deep trough developing between the Great Lakes and the Hudson Bay. Now the pattern isn't blocked up here, but this trough is going to hang around for a little while. What's problematic about removing the trough and bringing in the warm air to stay is as I move this on out, this is now through this weekend into Sunday, getting out into next Monday and Tuesday. In general, the flow of the atmosphere is coming like this out of the Pacific. Whoops, let's try that again. It's coming like this out of the Pacific, okay? And then you notice that it's going like that over into the Atlantic. Now, the flow is not coming strongly like this, which would give us a lot more severe weather, which would give us a lot more routine heavy rainfall, and this would return the moisture to the northern plains. It's the wrong trajectory coming in that direction, then kind of doing this check mark and bouncing off like that. So what does that end up getting us? Well, right now, if we look at our all hazards weather map, got some stronger winds today and red flag warning. And you see south of it, this is all frost advisory. So we need to be talking about temperatures and winds here as we look forward. First, though, let's at least get into some precipitation. So early this morning, a very weak little wave coming through the flow is going through Illinois, and that's going to bring some scattered precipitation into that part of the Corn Belt, as you see right here throughout the day today. All right. That then moves into the northeast, and there's another wave that comes behind it, a cold front right here on Friday that slides through the Great Lakes states. Once we get into Friday evening and then work our way into Saturday morning, what happens is that there's this frontal boundary that sits right in here like this, and a low that begins to form in this area. And here's the precipitation we've been talking about that's going to come back to parts of Montana and the western Dakotas. But it appears in the forecast that it has a difficult time getting into the Red River Valley of the north and eventually into the upper Midwest. To show you that, let's go over to the European model. So as we play this forward, let's get to the point where we saw that low emerge, which is right here. So the low comes out of the panhandles, and on the northern side of it where that frontal boundary sits right here, and again, it's connected to the exiting low that's going into the northeast. That is going to be the trajectory, so that frontal boundary that this low is going to follow. It's going to follow that temperature gradient. So watch. This is going into Sunday morning, Sunday midday, Sunday evening. Now I just going to give out a quick apology to every mother out there who kind of lives in, let's draw this here, it lives in this corridor, because in that area on Sunday, it's going to be soggy. It is going to be actually very cold on the northern side of this, right in through here, and we're even going to be dealing with some winds. So I'm sorry, that is the forecast for that area. That system then pulls on off toward the northeast by the time we get into Monday, and it's going to leave a boundary down here across the south. And what that boundary is going to do is, this is getting into Tuesday morning. Can you almost see it linking up there? It's what's going to keep the risk of storms going in this area. So this is now getting out to Tuesday evening, getting out now into next Wednesday morning, afternoon, and evening. And do you just see how the high pressure centers here, that frontal boundary is stalled out in this area? We're going to continue to see the storms going here. Well, that gets us all the way out to 1 week. Let's add up all that precipitation. So as I play this forward, here we are getting through Friday, now getting through the day on Saturday. This is Sunday morning, Sunday afternoon, Sunday evening. And as we pull into next week, this is now getting through the day on Monday, Tuesday, Wednesday, and we'll stop it right out here at a week's forecast. So what you notice is how sharp of a gradient to the north we have that precipitation. Dry in the west. Seems to be a sharp line right here as well. But in this corridor here, there's a high probability of getting well in excess of 1 inch of rainfall, some places over 2 inches of rainfall. The GFS has a similar picture to paint here. There are some differences. So that's the GFS. Here's the European. You can see the differences. European, GFS. But as we stretch this out and look at what those precipitation anomalies look like, this is going to be an area that, despite some of the cooler weather coming in, is going to be quite dry. Let's keep an eye on that upper Midwest Great Lakes region. The west is also very dry during this time period too. Getting out there and just looking at the precipitation anomalies, what I want to first focus on is the last 30 days. We've discussed how dry the west has been, but there's a couple of pockets I just want to make sure that we note here, especially this part of Minnesota and Iowa, and then stretching right here into lower Michigan. And look at over here along the coast. From there, let's just take a look at what this pattern does. The GFS washes almost all the great signals out by day 10. It's trying to split the flow, have things come back together to ridge here and let this trough exit on out. The European has a little bit different scenario here. It's now got a flow that's, and I'm telling you that these models through mid-May they've got no clue on this pattern, unfortunately. So what are they doing in terms of precip? Well, they're trying to bring the precip back to an area that would desperately need it. And I look at that and I go, well, what about that flow pattern would really do that? Because you have to have this trough here to sweep through the northern plains to make that happen. But the signal on this trough is relatively weak. And I have seen many times this spring that the model says, yeah, drop a trough in there and bring in the rain to the northern plains. And it just doesn't happen. So that's the the European solution for week 2. And here's the GFS. It's attempting to do the same thing. Do you notice it? And I'm just going to call into question this whole pattern out into week 2 because I think the models are too washed out on what's going on. What I do know is in the near term, we need to watch how these temperatures are going to change. Because over the last 7 days, we have seen quite a bit of cold air become kind of stored here in the northern part of the Canadian prairie. And it's about to change our patterns quite considerably. Let's take a look. Overnight low temperatures first. We had a frost this morning in parts of the northern plains. As we play this forward, this is Friday morning's lows. The color shading tells you difference from normal. This is now getting into Saturday. Now, what I want to pay close attention to is on Saturday, if you're kind of north of that line right there, okay, that is going to be the area that we're going to have a frost risk. And what I mean by that is this is not the depth of cold we saw a year ago where I remember, right, like Fort Wayne, Indiana hit, I believe, 18 degrees Fahrenheit. Okay, this May 8th, we're going to just see those temperatures right before dawn drop down there into that freezing area, so 32 degrees. And then as we go into the day on Sunday, we continue to see that frost risk in this area. But the cooler air hangs on through the 10th, into the 11th and 12th as well before moderation begins. I think the pattern breaks back for warmth after the 12th. Look at these high temperatures here. This is Thursday's highs compared to normal. Look how warm the west is. There's Friday. As we get into Saturday, now we start to see where that frontal boundary is going to be. You can almost just find it right there. See that? And then as we go into Sunday, it pivots. And this is where I told you Sunday's going to be miserable in this area. Some places here probably maybe not even getting up into these 50s right around where I live. I've already apologized to my mom over this. But if you go back, look at the West Coast. So we've got, well, upper 80s to lower 90s today along the Central Valley of California. Cooler day on Friday, back upper 80s on Saturday. And even as we get into next week, this is Monday, they're in the 90s. Tuesday, mid to upper 90s. And next Wednesdays, we finally start to see that cooler air get out of there. The west still stays very warm, especially in the Central Valley of California. And we talked about winds earlier, remember that? Well, this is what the accumulated wind gusts look like as that system emerges. And I see some very strong winds here and strong winds in the plains emerging as that next low pops out and runs right like this, okay? Thinking about these strong winds here, take a look at the evaporation rates over the next week. We could have the northern part of the Central Valley, so this is called the Sacramento Valley here, have over 3 inches of evaporation. I mean, after the dryness we've experienced for the last 6 months, this is a high evaporation rate this early in the season. Let's get to the end of this video. Temperatures day 5 through 10. Okay, the cooler air is exiting at that point. Going out here into the European, you can also see it. So we're now moving this cooler air, which is going to be about 5 or 6 degrees below normal, and be moving it on off to the east, such that by the time we get out there to day 10 through 15, we start to see the temperatures really moderating again. Okay, same thing in the GFS. From there, longer term, MJO. Well, much of what's going on right now is because the MJO came way out here at high amplitude into phase 1. These are the cooler phases. These would be the warmer phases for the most part. And if the MJO does come back into this direction, that would signal toward the middle and end of May, we start to break the pattern and we go back over warm. And the models are seeing that. This would be May 20th through the 27th. Look, and we just kind of slide this forward. We start to see the warmth returning. One thing I do note, the West is going to stay warm throughout much of May and into June. And that's the number one thing I want you to watch. I had a lot today. I appreciate your attention. I hope you found this instructive and useful, but we're going to wrap it up here. Thanks.